All right. As we get started for today, I don't have all the quizzes graded yet. I don't have third hours graded yet. So those I will hopefully have graded by Monday. So between now and then. But we are, ladies walking in, close, like how the door was closed when you came in. Did you close it? Thank you. We are graphing, moving on to 2.6, which we're covering today and Monday. We are graphing piecewise defined functions. So these graphs are a little different. I don't have this written on the front board yet, but the next homework quiz is just on 2.6. So between today and Monday, the different types of graphs that we do. Today, the piecewise defined functions you're going to see will look like you see on here, where you actually see there's multiple pieces, there's multiple equations. The ones on Monday, even though they're piecewise, they're given as one equation, but you have to know that they're made up of multiple pieces. So that's what our focus is between today and Monday, is being able to not only graph for today, but then write a piecewise defined function. So if I give you the function, you can graph it, or if I give you the graph, you can write it. Lizzie, you can go ahead and sharpen it. Okay. Yep. So starting out, this also kind of depending on when you took Algebra 1, who you took it with, I know when I used to teach Algebra 1, piecewise defined functions is in Algebra 1. It's definitely not a focus. But in the past, I know I've had students that remember graphing these, and then students that were just totally unfamiliar with graphing them. So I teach it as if you haven't graphed these before. But you're going to see, like I said, multiple pieces. You can actually see if you flip it to the back, this is what they look like. So when you see three equations in one function, you're going to see three pieces of a graph. So it's comprised of rays and line segments, not lines that extend forever in either direction. But all of the pieces are linear. So a piecewise defined function, the formal definition is a function written using two or more expressions. So we're going to go through two examples together of graphing these. You can see the first one has two expressions, and then the second one has three expressions. So actually, I'll fill this in. These here are your expressions. And then all the pieces, they don't have to be this way, but all of the pieces that we are graphing are linear. So you can have a piecewise defined function where there's non-linear expressions in there. We're not doing that since we've only really been working with linear, or this chapter is also focused on linear functions. And so all these expressions, remember the f of x, that is like your y. So that's your y equals. And then these will all be in the form of mx plus b. So you'll see a slope and a y-intercept. They're all linear. And then on these graphs also, you're going to see some points we fill in with just like you would normally plot a point with a dot. You may also see open circles. So we'll go, when we get to that part, we'll go over how you know whether to use a dot or a circle. But you're going to see both, and I'll explain why there's both also. So notice for each expression, it gives an if. So these here, the inequalities for x, these are the domains that correspond with the expression. So these here are the domains for the expressions. It is not what you list though, because notice we're graphing and giving the domain and range. So the domain down here, we're not just listing these, you're finding the domain of the entire thing. So this means for this one expression, this is the domain. For this expression, this is the domain. So here's how I graph them. This is, in my opinion, a way that kind of makes more sense to everybody in terms of graphing these. But certainly as you go through it, if you don't need to set it up the exact same way I do, I'm just looking to see that you can graph it. But what I typically do is for each of my expressions, I set up a table. So I'm going to write these down. I have y equals x minus 2, and then I also have y equals x plus 3. And for each of these, if I was just graphing one line, I wouldn't graph this making a table. I can graph using point slope form. But for the purposes of this, and you'll see why with the domains, I make a table for these. And then I'm also going to write next to them just as a reminder to myself, for the y equals x minus 2, this is only defined, the domain is only for x values less than -1. And then the x plus 3, this is only defined for x values that are greater than or equal to -1. Remember too, if you forget which inequality symbol is which, because I don't want that part to mess you up, like if you're thinking this is greater than -1, that's going to mess you up when you graph. Make them on your hands to remind yourself less than is on the left, so less than smaller than is on your left hand. So what we need these for, so in each of the tables, we know when we make a table, we first fill in the x values that we're going to substitute in. I always refer to the numbers that are in these inequalities, so this -1 in this case, I refer to that as the endpoint. The endpoint should always be in your table. So both of these tables, I'm going to put -1 in first. I'm putting -1 into this table, even though it's just less than -1, it can't actually equal -1, I still put it in there. So whatever that endpoint is should be, well, I usually put it as the first number in each table, but it definitely should be in each table. And then the rest of the x values for this first one, x minus 2, the rest of my x values should be less than -1. And I usually just do a few points, so I would do -2, -3. But it could be any x value that's less than -1. And then the other table, my remaining x value should be greater than -1. So I'll do 0 and 1. So the only x value they share is that endpoint value. Then I substitute the x values into their corresponding equations. So I'm going to substitute these 3 into x minus 2 to get my y's. So when x is -1, -1 minus 2 is -3. Then -2 minus 2 is -4. And -3 minus 2 is -5. And then I'll go over here and do the same thing. So I'm substituting these into x plus 3. So -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. And then when I graph these, so this is what it was referring to up here when it said sometimes there's dots, sometimes there's circles. So just like when you're graphing an inequality on a number line, a dot indicates the point is included in the graph, and then an open circle will indicate the point is not included in the graph. So we know that with functions, we cannot have one x value paired with multiple y values. Right now, this endpoint that has the x value -1 is paired with both -3 and 2. So the dot versus circle only corresponds or only kind of refers to your endpoint x value, or x values if you have more than one. One of these is going to be a dot, the other one's a circle. The rest of the points are just like normal when you plot them, they're dots. So here, this one, because x is strictly less than -1, x does not include, -1 is not included, x cannot equal -1. This one is going to be a circle, an open circle. So when I plot that point, I just put an open circle, and again, it's because x equals -1, not included in that domain. But -1 is included for this one, so this point is going to be a dot, a closed dot. because x equals -1 is included. Okay, again, the rest of the points, so it doesn't mean that all of the points in this first table are all circles. It's just that end point. So now when I graph this, I'm going to start with the y equals x minus 2. So I'm going to plot -1, -3 with an open circle. The rest of the points I can just put points, dots. So -2, -4, and then -3, -5. And remember when I had flipped it and I showed you this, you're not drawing lines that go through or extend through both directions. You're drawing rays or segments. So I start at my end point and I just draw a ray through the other points that I plotted. And that is that piece of my graph. So that is the part of the line y equals x minus 2, but only for these x values. Then I do the same thing for the x plus 3. I plot the end point, so -1, 2, and that is a dot. And then the 0, 3, and the 1, 4. And I draw another ray. So I start at my end point of -1, 2, and I draw a ray. This one is extending up and to the right. That is the graph of that piecewise function. Okay, there's two pieces. Now here's a way for you to double check, and this also comes with just understanding functions. Your graph should pass the vertical line test. These are all, like it says in the title of the lesson, these are all functions. It should pass the vertical line test. So anywhere I draw a vertical line, I should not be passing through more than one point. That is why at the x value -1, one of these is a dot, the other one's a circle, because when I draw a vertical line, this is an actual point, this is not. It's just the end point for this line. This is saying this point isn't really there, it's just kind of a placeholder. And then this is a circle, so when I pass through, this is actually the y value when x is -1. Connor? It does, yeah, it does matter. It has to do with your inequalities for your domains. So if it has the equal to, just like on a number line, then it's dot, yep. And if it doesn't have the equal to, it's a circle. So it's same thing from chapter 1 with the number lines. Think of it that way. Okay, but that's your double check. Like if I had accidentally plugged in the wrong x values and this one was going this way instead, I'd say, well, that's wrong, because then when I draw a vertical line, I'm passing through two different lines. Questions on that graphing part? And we are going to do a second example. Then domain and range. This is the domain and range for the whole graph. Domain is your x values, range is your y values. So for domain, again, if you're having trouble finding these, because domain and range, it's not the same for every single one. So as you're doing the practice, if you have questions, you have trouble finding domain and range, please ask for help. But here's how I'm going to explain it. Domain, since it does correspond, or it is the x values. So I think of it when I have a graph of bringing my graph. If I were to bring it to the x-axis, what part of my x-axis would be filled in? What x values am I using? So if I were to bring this part to the x-axis, my endpoint, if I bring that up to the x-axis, it would be an open circle at -1. And then because this ray is extending, it's going down, but it's also going to the left. So that means every value less than -1 is covered, is shaded. Then if I bring this part to the x-axis, this end point, when I bring it down, now the -1 wasn't filled in here, but it is here. So now the -1 is included. This one is going up, but also to the right forever. So by doing that, I notice my entire x-axis is highlighted, meaning x can be any real number. X can be all real numbers. So my domain, I'm going to write it in set builder notation. I know we did this like for one example in 2.1, but in set builder, it's all x values such that x is an element of the real numbers. So that E, that's kind of like a C with a line, is the element of. I had showed you that, again, briefly in 2.1. And then for the range, I'm going to do the same thing, but bring everything over to the y-axis. So if I were to bring this bottom piece over to the y-axis, my endpoint would be at the y value -3, but it's an open circle. And then this part is extending down. So those values are all filled in. And then this piece, if I were to bring it over, the endpoint is at the y value 2, and it is filled in. And then that part is extending upwards. So the range is not all real numbers for this one. It could be with other examples. For this one, it's not, because you can see there's some values in between here that are not included for y. So I'm going to have two inequalities I have to list, and I usually do like lowest to highest. So for this piece, I'll have all y values such that this piece is not including -3, but includes everything less than -3. So y is strictly less than -3. And then I'd have or, because they're not sharing any values. This piece includes +2 and everything greater than 2. So y would be greater than or equal to +2. So that would be my range. Okay, questions on that? And like I said, these domain and range are always different. Domain is not always all real numbers. Range, again, it just depends on your graph that you're making. So as you're doing that practice, please let me know if you're just struggling finding domain and range, because that tends to be tough. We'll look at example 2. So same idea. This one has 3 pieces. So on our graph, we're going to have 3 pieces. The middle one, when you have 3 or more, even more than that, these 2 outside ones are going to end up being rays like these 2 were. The middle one is going to be a segment. And you can kind of see that when you flip to the back, because there's 3 pieces on that one. One of them is a segment. So again, I'm going to set up 3 tables this time. This one is just y equals -3. The middle one is y equals x. And the last one is y equals -x plus 6. And just so I can move this up, I'll write these next to it too. This first one is for x values less than or equal to -4. The middle one, so remember this compound inequality means x is really between -4 and 2, or you can read this as x is greater than -4 and also less than 2. But just like it shows x is between those 2 numbers, and the last one, x is greater than or equal to 2. So always substitute in the endpoints into your tables. So in this one, I will substitute in the -4. My remaining x values then should be less than -4. So I'll do -5 and -6. But the -4 should definitely be in there. In the middle one, because you have 2 endpoints, both go into your table. So -4 and 2. And then this is going to be a segment, like I said. You're going to have 2 endpoints, you just connect them. So it's up to you. You could substitute in a value that's in between them, but you don't really need to. As long as you have those 2 points plotted and you connect them, you don't really need to plot another point in between unless you want to. And then the last one, I should definitely substitute in 2 first, and then the other value should be greater than 2. So I'll do 3 and 4. Okay, so I'll start with this first one. I'm going to substitute these 3 into, well, actually, I don't have an x value to substitute it in. So what am I doing for y here? The y, this means y is always just the number -3. So no matter what x is, my y value is just always -3. Because I have nowhere to put x in. In the middle piece, when I substitute x in, the y value is just the same as the x value, so y will be -4 and then 2. And then for the last one, if I substitute in 2, I have -2 plus 6, so 4. And then putting in 3, -3 plus 6 is 3. And then 4 is -4 plus 6, so 2. Okay, so starting with the y equals -3, should the -4, -3, should that endpoint here be a circle or a dot? Should be a dot, because it has the equal to, it includes -4. So -4, -3 is a dot, and then -5, -3, -6, -3. So when you have y equals a number, that's just a horizontal piece. There's no slope. So that will be a ray extending out to the left. Then for the middle piece, these are both endpoints. Should the -4, -4 be a circle or a dot? And what about the 2, 2? That's also a circle. They're both circles because neither one is included. It's not equal to. So -4, -4 is a circle. 2, 2 is a circle. And like I said, it's a segment, so they're just connected. And then the last one, the endpoint 2, 4, circle or dot. That should be dot closed because it can equal to. So 2, 4 is a dot, and then 3, 3, and 4, 2. And that one is a ray. So starting at the 2, 4, and this one extends down and to the right. So that's your graph. And again, you can double check. It should pass the vertical line test. So the only place we have overlap is at the -4 and the 2, but we do have one dot and one circle. There's no overlap anywhere else. So nothing should be crossing or overlapping each other. Then it's not a function. Domain for this one. Again, I'll explain like I explained this, just to give that other explanation if you didn't quite understand it. So if I'm bringing everything to the x-axis for the domain. So if I bring this up, it's a dot at -4 and everything less than that is shaded. Then my middle segment has a circle at -4, but -4 is already included from this dot here. And then a circle at 2, and it includes everything in between. And then my last piece has the dot at 2, so now 2 is also included, and everything to the right. So everything ends up getting shaded on the x-axis, so the domain is all real numbers again. So x, such that x is an element of the real numbers. And then range, I'll start with my leftmost piece. So this horizontal ray here, if I bring that over to the y-axis, it is only at the y value -3. So the range for that piece is just the number -3. For the middle piece, the segment, that would be a y value of -4, but it's not included. Up to a y value of 2, that's also not included, but it does include everything in between. So right now we have everything from -4 up to -2. And then this last piece, if I bring it over, has a dot at 4, so 4 is included, and then it includes everything less than that. So even though these, the 2 and the -4 were circles because of the segment, now they are included by that last piece. Okay, so notice once I move all 3 of my pieces to the y-axis, my range is really just any number that is 4 or smaller. So it's Yes, so it's y such that y is less than or equal to 4. So it's just one inequality. So just because there's 3 pieces doesn't mean your range is going to be 3 different inequalities. It could be, but these tend to, or that last one kind of includes the other 2. Okay, questions there? Okay, so that's graphing, and you'll have practice with that. I just want to go through, I know there's 2 examples on the back. We're just going to do one. This is now the reverse. If I give you the graph, I want you to be able to give me the function. So your answer, because there's 3 pieces here, so your answer is going to look like this. You're writing this. Do you need to go right now? You're going to miss the last example. Okay. Okay, so I'm going to set this up since I know there's 3 pieces. I know it's going to be f of x equals, and this is just for me, so I am organizing what I need to fill in. So I'm going to have 3 expressions, and then for each of those expressions, they have a domain, which is your inequalities for x. And all of these expressions, because each piece is linear, again, should be in the form mx plus b. So what that means is for each piece on the graph, we need to figure out what the slope is and then what the y-intercept is in order to write the expressions and then find their corresponding domains. And I usually work left to right on the graph so that the domains are in order, kind of like we've been graphing them. So I'm going to start with this leftmost piece. How do you find slope from a graph? Rise over run. So I have my endpoint up here. I'm just going to mark here, this is the y-intercept actually. So if I were to do rise over run from one point to the next, I'm going up 2 and right 1. So my slope is 2 over 1, which is 2. And then my y-intercept, my b, I had already marked is at 1, 2, 3. So that would be the line y equals 2x plus 3. You don't have to put the y equals though, because you already have the f of x equals out here. So it's just the 2x plus 3. And then we need the domain for that piece. Did you have a question or do you have the... Depending. By the test, I would probably take off some because you already have the y equals here. If it happens, say on like the homework quiz, I'd probably just cross it out to remind you don't need it. But just as long as you realize right here, the f of x equals is your y equals already. So if you put it again, it's just not really necessary. And then for the domain, again, it's like you're bringing this piece to the x-axis. So start at your end point. If I were to bring that down to the x-axis, the end point is at the x value 1. I'll do this. The x value 1, and then it's everything to the left of that. And then the 1 is a circle, so it's not included. So it's every value that is less than 1. So that would be my domain. X is less than 1. Okay, now I'm going to do the middle segment here. So for that middle segment, what would you say the slope is? I heard 1 and I heard -1. -1 because it's going down. You're going down 1, right 1, so it is -1. And then y-intercept. So even though this segment, the way it's drawn, doesn't cross the y-axis, you then just have to kind of continue it to the y-axis to see where it would cross. So if I like go up 1 over to left 1, up 1 over 1, it would cross at the y value 2. So the y-intercept would be 2. So this would be -1x plus 2 or just -x plus 2. And then for this domain, If I were to bring kind of this piece down, that's at the x value 1 and it is included, and then it goes to the x value 2, which is included, and it's everything in between. So this is x values between 1 and 2, and they're included. So we would write it this way, like that compound inequality. So 1 is less than or equal to x, which is less than or equal to 2. They are both less than or equal to symbols, because remember that middle one, or this first piece, you kind of read backwards. X is really greater than or equal to 1. And then the last piece is the horizontal piece up here. What's the slope of a horizontal line? 0. There's no rise. And then the y-intercept, if you just shifted it over, it would cross through 3. Everything is at the y value 3. So this is 0x plus 3, but you don't need the 0x there. If you included it, I wouldn't take off. But that is just 3. So just the number are the horizontal pieces, because that means you don't have a slope. And then the domain, if I were to bring this down, it's at the x value 2, but it's not included, and then everything bigger than that. So the x values would be strictly greater than 2. And this is your answer. That is the function that is graphed. Okay, so it's practicing, yes, it's piecewise, but it's also practicing writing the equation from a graph, finding the domain from a graph is all included in that as well.